We think black holes are the most terrifying things in the universe, but they are not. For decades, these cosmic monsters have captured our imagination, symbolizing the ultimate cosmic abyss from which nothing, not even light, can escape. We picture them as relentless vacuum cleaners of the cosmos, swallowing stars, planets, and entire galaxies. The idea of falling into one, being stretched into a noodle by immense gravitational forces in a process called spaghettification, is the stuff of nightmares. But what if I told you there are far more insidious, far more immediate, and far more destructive forces lurking in the cosmos? Things that could erase us from existence in the blink of an eye, without any warning at all. These are the true cosmic horrors, making black holes seem almost tame by comparison. Stick with me as we journey beyond the event horizon of our fears and discover what truly keeps astronomers up at night. First, let's get our facts straight about black holes. They are indeed formidable. A black hole is a region of space-time where gravity is so strong that nothing can escape from it. They form when massive stars, much larger than our sun, collapse at the end of their lives. The star's core implodes under its own gravity, squeezing an immense amount of mass into an infinitesimally small point called a singularity. Surrounding this singularity is the event horizon, the point of no return. Once you cross it, you're gone for good. And yes, they are powerful. A supermassive black hole at the center of a galaxy can dictate the motion of billions of stars. If one were to wander too close to our solar system, it would wreak havoc, flinging planets out of their orbits and eventually consuming our sun. But here's the key. They are predictable. We can see them coming. We can detect their gravitational influence on nearby stars and gas. They are the lumbering giants of the universe. Dangerous, yes, but not sneaky. The real terror lies in the things we can't see coming. Now, let's talk about the first of our true cosmic horrors, gamma ray bursts, or GRBs. Imagine the most powerful explosion in the universe since the Big Bang. That's a gamma ray burst. They are brilliant, high-energy explosions that we've observed in distant galaxies. Most of them are thought to originate from the collapse of a massive, rapidly spinning star into a black hole, or from the collision of two neutron stars. As the star collapses or the objects merge, they shoot out two narrow, incredibly powerful beams of gamma rays in opposite directions, like a cosmic death ray. These beams travel across the universe at the speed of light. Now, why is this so terrifying? If one of these beams were to hit Earth, it would be catastrophic. It would strip away our ozone layer in a matter of seconds. Without the ozone layer, we'd be exposed to deadly ultraviolet radiation from our own sun. This would trigger a mass extinction event, wiping out a significant portion of life on Earth, both on land and in the oceans. The scary part? We would have absolutely no warning. The gamma rays travel at the speed of light, so we wouldn't see the burst coming until it hit us. We'd just be going about our day, and then, instantly, our planet's protective shield would be gone. The sky would change, and life as we know it would begin to end. Some scientists even speculate that a past mass extinction event on Earth could have been caused by a GRB. Next on our list of cosmic nightmares is the magnetar. You've heard of neutron stars, the incredibly dense remnants of supernova explosions. They are so dense that a teaspoon of neutron star material would weigh about 1 billion tons. Now, imagine a neutron star with a magnetic field 1,000 trillion times stronger than Earth's. That's a magnetar. Their magnetic fields are the most powerful in the universe, so strong that they defy comprehension. This immense magnetic energy causes the star's crust to crack and shift, resulting in what are called starquakes. These starquakes release enormous bursts of energy in the form of X-rays and gamma rays. In 2004, a magnetar named SGR 180620, located about 50,000 light-years away, had a flare. In just 1/10 of a second, it released more energy than our sun has in the last 100,000 years. The radiation from this flare was so powerful that it traveled across the galaxy and measurably affected Earth's upper atmosphere. Now, 50,000 light-years is a safe distance. But what if a magnetar were much closer, say, within a few dozen light-years? The magnetic field alone would be disastrous. It could wipe every credit card, hard drive, and data storage device on the planet. It could even distort the electron shells of our own atoms, tearing apart the very molecules that make up our bodies and our world. The burst of radiation would be even worse, sterilizing the side of the planet facing it. Like GRBs, we'd have very little warning. A magnetar is a ticking time bomb, and we wouldn't know it was aimed at us until it was too late. So we have gamma ray bursts that can fry us from across the galaxy, and magnetars that can tear us apart atom by atom. But the ultimate cosmic horror, the one that makes all others seem insignificant, isn't an object at all. It's a theory called vacuum decay. This is where physics gets truly terrifying. According to our current understanding of particle physics, the universe exists in a certain energy state. This state, our vacuum, is stable, but it might not be the most stable state possible. It might be what physicists call a false vacuum. Imagine a ball resting in a small dip on the side of a large hill. It's stable for now, but if it gets a little nudge, it could roll all the way down to the bottom of the hill, a much more stable position. Our universe could be like that ball. If, somewhere in the cosmos, a small patch of space were to spontaneously tunnel into this true, lower energy vacuum state, it would trigger a chain reaction. A bubble of this true vacuum would expand outward in all directions at the speed of light. Inside this bubble, the fundamental laws of physics would be different. The properties of elementary particles like electrons and quarks would change. The forces that hold atoms together would cease to exist. As this bubble washed over Earth, everything, you, me, the planet, the sun, the entire galaxy, would be instantly obliterated. We wouldn't just die, we would cease to exist in any recognizable form. There would be no flash of light, no sound, no warning. One moment, the universe is here. The next, it's replaced by something utterly alien and inhospitable to our kind of existence. We would be deleted from reality itself. We've journeyed through the cosmos and faced down gamma ray bursts, magnetars, and the mind-bending concept of vacuum decay. These forces operate on scales and with energies that make our earthly concerns seem trivial. They remind us that we live in a universe that is not only beautiful and wondrous, but also incredibly violent and unpredictable. Black holes, with their slow, predictable pull, are the known monsters. But these other phenomena are the silent assassins, the cosmic accidents waiting to happen. Which brings us to the final chilling question. Could it happen to us? Could a beam from a dying star already be speeding towards us? Is there a magnetar in our cosmic neighborhood just waiting to erupt? Or could the very fabric of our reality unravel at any moment without any cause or warning? Statistically, the chances of any of these events happening in our lifetime are incredibly small. But they are not zero. The universe is more fragile than we think. Thank you for joining me on this journey into the terrifying side of cosmology. If you found this mind-bending, don't forget to hit that like button, subscribe, and ring the bell so you don't miss our next exploration into the unknown. What do you think is the scariest thing in the universe? Let me know in the comments below. Until next time, keep looking up.